Meu nome é Anderson e eu sou de São Paulo, Brasil. In September 2021, I joined the chair of Risk, Safety and Uncertainty Quantification at ETH in Zürich, Switzerland, one of the university beneficiaries of the GREYDIENT project. And my project here is entitled Uncertainty Quantification and Reliability Analysis for Noisy Gray Box Models. It is mainly concerned with the system's performance, which is the reliability analysis. Essentially, I'm always trying to assess the probability of failure of a system, and because this probability of failure is very small, it is actually very hard to find it. It is like looking for a needle in a haystack. But what does it have to do with gray box models? Well, when dealing with a gray box model, we combine two types of models. The white box model, which is a simulator that relies on the physics of the problem, and the other type of model, the black box model, is a data-driven model. The thing is that for this data-driven model to work, we need real-world data, and this data has to be measured somehow. And because we are measuring the data, we are introducing what we call epistemic noise to our problem. The problem with having noise in this system is that it hinders the assessment of the probability of failure. And theoretically, we can filter the epistemic noise out of the problem, but on top of that, there is also a particular class of simulators called stochastic simulators. And these kinds of simulators, they introduce what we call aleatory noise to the problem. This kind of noise is trickier than the epistemic noise because unlike the epistemic noise, we cannot filter this out of the problem. So my goal here in the project is to formalize the problem of having these two types of noise introduced into the gray box models and develop new ways of performing reliability analysis in the presence of these two kinds of noise. By doing this, we aim to achieve safer and more reliable and cost-efficient systems.